This meeting is being recorded.
In problem 12 from chapter 4, we're asked to draw bond line structures for each of these compounds that are named in parts A, B, and C here. So um, I have the structures with the carbons numbered here for us. So let's take a look here at the answer for A. And we see that our parent is named as a bicycloheptane. So that means that our two fused rings together have 7 carbons. So we can see that we start numbering at this bridgehead here. We go around our largest ring. That one has 6 carbons. So we would draw it like so, right? We would draw this 6-membered ring showing its 3-dimensionality. And then we can take a look at our bridges to confirm that we've drawn the right structure, noting that we have only one carbon in our shortest bridge. So carbon 7 up top there is a 1-carbon bridge. And we see two carbon bridges down below. So again, our longest bridge here has 2 carbons. This is equivalent. It's also a 2-carbon bridge. And then we have a 1-carbon bridge. So we've confirmed the structure against our name so far. And then we just have to confirm that our when we draw this, that our substituents are on the correct carbons, and in this case, they would be on a 2, 2, and 3, 3, for a total of 4 methyl groups. And we see if we started at that bridgehead with our number 1, we would get to the lowest numbering going down this bridge. So we would go this way first. So we would see carbon 2 and then 2 more methyl groups on carbon 3. So this is the correct structure for the named compound A. Let's take a look at B here. So now we have 8 carbons total in our 2 cyclic compounds. We have a bridge of 3, a bridge of 2, and then a bridge of 1. So our shortest bridge is up top here with that 1 carbon, and we see that we have a bridge of 1, 2, 3 carbons here, and then 1, 2 carbons here, for a total of 7 carbons in our largest ring. And let's start numbering that ring. We have to go down the largest bridge. So we could go this way, or we could have started at this bridgehead and gone this way. We still would have found 1 through 5 along this ring. And then continuing, we would see in this ring here, the other 2 carbons give us 6 and 7. And then that last bridge of 1 carbon, when we go to the top, we see that that's numbered carbon 8. And that's where we have both of our substituents, and they're the same substituents. So they're 8,8 diethyl would be drawn like this, 2 carbon substituents coming out of that carbon 8. And we have 2 of those, 2 carbon substituents. So that is the correct structure for the named compound B. Let's look at C here. We have 3 isopropyl bicyclo 3,2,0-heptane. So we're looking for 7 carbons to be drawn in our 2 cyclic structures, and we see that we have a 3, a 2, and a 0. So what that tells us is that the 2 rings share an edge. So that's why we have placed here a 3-carbon bridge next to a 2-carbon bridge, and between them is our 3rd bridge with 0 additional carbons. So whenever you see that 0 as part of your parent name, you know that your 2 cyclic structures would then share an edge. So this confirms, right, that we have 2 bridges that total 7 carbons, right? We have 5 in our larger cyclic structure, and then over here we have a 4-carbon cyclic structure, but 2 of those are used as bridgeheads. So we want to number our substituent. The lowest, we have 1 substituent over here. This is an isopropyl for the common name for this substituent. Right, so we know that we have the right group drawn over here on our carbon 3. So again, we could start at either this bridgehead up top or this bridgehead down here. And we would go down our largest bridge, whichever way, and we would end up on carbon 3 here, showing that substituent of the isopropyl group. So this is the correct structure then for compound C.